So this is another video which will probably be a little messy because I won't have a great deal of time to edit it, but I wanted to go through some of the stuff we've covered in classes so that those people who are struggling a little bit with what we've done, or those people who weren't able to get to the class, will have something to go back to and learn from. So this time we're going to look at some very basic sequencing of notes. Now, of course, Live does this itself in its clip view. That will run through a series of loops. But apart from anything else, it's quite useful to know how to do this in Max. It will give you an understanding, or a deeper understanding, of some of the concepts we've already looked at, along with some additional ones. And also because there are certain things that you might be able to add to your own kind of clip or loop sequencer that Ableton's own devices won't do, or its kind of native architecture won't allow. So we're going to start basic, and I'm going to open this first sequencing thing, which is here. Okay, so there's only two little kind of engines in this patch, and we won't spend too long on them because hopefully most of what's in here will be relatively familiar to you. If it isn't, obviously we're going to go through it a bit now. So the meat of this is within this red box, but basically what we're doing is taking a count from the Live engine. So when you have the transport running, then data is coming into the Max object, and is this abstraction here, which is a subpatch which I've made myself, is translating the data from Ableton into a count, which is then being used to drive this part of the patch. So I'll come back to this Live time counter in a minute. I said that I built it. Actually, I've used another tutorial which I will be pointing you to give me inspiration as to how to build that, but it's quite useful. So anyway, this gate is allowing this time count through, and it will drive, if I lock the patch, it will drive when I turn the transport on. There we go. And solo that track, there we go. Okay, so that's counting through that sequence. Basically, the counter, which you can see here, is giving a number from 1 to 8, and as it goes through the select object, each one of those numbers is coming in, and each one of these numbers is associated with an outlet. So the first number, which could be any number, but it just happens to be 1, is sending it whenever the number comes in and is recognised by this select sequence of arguments, then it sends a bang out of the respective outlets. So basically we're sending it a bang in sequence as it counts through this count through each of these outlets in turn. And then each of those outlets, or each of those bangs, is going into a button object which is just being used for display, and then into these message boxes which have numbers in them. And these numbers are MIDI, well, we're considering them as MIDI note numbers. So this first one is 60, which is middle C, 64 is E, G, C above middle C, E, G, C, and then E. So we're going through a kind of arpeggiated sequence. And so we see this number in turn. They're all being routed to the number box here in turn. So we get a sequence of MIDI pitches, which is being sent to a very, very simple synth that I've built, which is, again, hopefully familiar to you from some of the synthesis stuff we've looked at in the past. It's just a sine wave oscillator and a simple envelope. So this patch is very simple, but it does the job of doing an arpeggio. This one over here develops that idea a little bit, because this first one doesn't allow us to change the numbers in these message boxes, so we just get that repeated sequence of repeated arpeggiated sequence, which is a bit dull. So over here we've got essentially the same engine. So select object going into button objects, again just for display, and then through into these message boxes which contain the note numbers for our sequence, and they're different from the ones over here, so of course we get different notes. What's different is that we now have this unpack object, which takes a sequence of 8 numbers which are configured in a list as a single message, and then distributes them or splits them out into these various outlets. So if you have 8 arguments, then you have 8 outlets, and each number that's being sent in, or each element of the list, is translated into each one of these outlets. So if I click on this top one here, then of course these message boxes are updated and we get that sequence through as expected. When we get to the end of this sequence, as long as I press the button at the right time, which I don't always, then we get the appropriate sequence and we get the, whoops, there you are, got it wrong again. But we can update those numbers. And the fact that I'm not necessarily triggering these at the right time is perhaps of significance, and we'll come back to in a minute. Let's turn that off. So again, a fairly basic sequence generator. It's not particularly beautiful. It does the job, but it's perhaps not the ideal interface, but it works. So let's move on to the next one. Okay, so here we've got what appears to be an even simpler engine, driven by the same thing. This time we have a count of 16 rather than of 8, and we're using an itable object to store our note values. So before we were using message boxes and they had numbers in them. Now we have a table, so each one of these columns has a setting in it, which give us a number from 0 at the bottom to 127 at the top. So depending obviously on where you scratch in your blip vertically, then that will give you an appropriate note. So if we play that, oops, unlock it again. So we have a sequence which is seemingly rather arbitrary, but again it works. So what essentially is happening here is that we have a counter which is counting from 1 to 16, and we're using this table object whose x values, as you see from the number display here, maybe I should make this bigger to make it a little bit clearer. Hopefully that helps a bit. If I hover the cursor over the left hand side of it, we see that its x value goes from 0 to 15. So there are 16 available slots, as it were, in the table, but they run from 0 to 15 rather than from 1 to 16. Hence, from our number that comes in from our count, which runs from 1 to 16, we're taking away 1, which gives us 0 to 15, so it will count through the table. So the number coming in reads along the x values, spits out the y value, which is displayed at this number box, and then obviously drives our synth here. So that's how that's working, and it's fairly intuitive, fairly straightforward. And actually maybe now is a good time just to point out this live time counter which I mentioned before. This is not a native Max object. It's one that I mentioned before is an abstraction, which basically means it's a sub-patch or a patch which I've made and then saved outside this patch, this PB sequencer 2 device, and it's being called when I actually write in the name. So it has to be in the same file path. I do detail that elsewhere when we talk a bit more about such things as abstractions. I won't talk about exactly the kind of file hierarchy now. But anyway, double click on that and it opens the patch which we're running. I will talk very, very briefly about how this works. Basically, we are taking a sequence of or a signal count from from live, which is by virtue of this object translated into a value of 0 counting to 1 over the duration of 1 bar. So it's got 100 bars, beats, units as a frequency attribute, and that means that basically this count from 0 to 1 is happening every bar, so every time it runs through one of these loop points. And that value of 0 to 1, which actually I suppose I could show you. There we go. It's counting from 0 to 1, as you can see. Now it's coming in as a signal value. We don't necessarily want it as a signal value, so this snapshot object is converting it to control value, hence the changes of cable from this stripy line to the grey line here. And so if I put a non-signal number box there, then we see that now this is counting again from 0 to 1. And then we're scaling that value to, and don't be misled by the arguments that are in here because they're not the right ones. What am I doing? I need to lock this again so we see the original values. So we send the count that we actually want in by virtue of this #1 number. Again, I don't really need to talk much about that, but we are basically using the scale object to give us the correct count, which in this case is counting from 0 to 1 above the value that we actually want. So we want to count from 1 to 16. This is just adding 1, so it would be a scaling from 1 to 17. It never actually gets to 17 because as soon as it reaches the end of 16 it loops back to 1, because this is just counting from 0 to 1. So in fact, we're, as I say, this whole object is counting from 1 to 16 over the time we specify. If I put in a different argument down here, so live time counter 8, then it would send in an 8 plus 1, which is 9, but it would count from 0 to 8 over the entire duration of the bar. I hope that I probably shouldn't have gone over that in this particular tutorial, but for those who kind of get it, then hopefully that will make a bit of sense. Yeah, you might find a better explanation or a different explanation at this link, which is where I got this from. But anyway, let's forget about that, because this is all doing the job for us. And you could, if you want to, you can copy and paste this into your patch and just use it as it is. Just point out that you've borrowed it from somewhere. That's not a problem. This is when you do your ultimate project. I did tell you that I might ramble a bit and that I hadn't got time to edit this, so apologies for that. Right, so we can have a look at some of these exercises over here, and I will try and get through them reasonably quickly. So the first thing that you might notice is that as this sequence runs through, we have this rather arbitrary set of pitches, which is all well and good, but it's not particularly musical. We might want to somehow constrain our values, because at the moment they just run from 0 to 127. There's no kind of limit on the numbers that we have in there, or the pitches that we have in there. We might want to, for example, constrain our kind of table to a different sort of values, but we might want to constrain our table to notes on the diatonic scale, for example. Again, at the moment they're all over the place. We could figure out what these are. Like that, but perhaps we can't be bothered. So what I'm proposing is that we constrain our notes to a for example, pentatonic scale. And for that we're going to use something which is very similar to the table object, which is this col object here. Col stands for collection, and its attribute, which is this @ sign here, embed 1, means that basically anything we make in the table and then save is going to be saved with the patch. So I'll save this and double click on it. Okay, so this is how you open the table. You close the patch and then double click on it, and it will come up with this text file, which is decidedly not thrilling, but it's very powerful. So what do we have in here? We have 2 numbers, one of which, the first one, is called an index, and that's a bit like the number that you send to table to have it read along the bottom and then spit out the number that's assigned to it. That's essentially what we're doing here. We're reading down the list according to the indices on the left hand side and spitting out a number that is associated with each index. So if col receives the number 0, then it will spit out the number 60. And you can add to this table. So this is the note C, this is a note D, this is a note E, and if I want to write in a pentatonic scale, the next notes would be a G, so 67, and then an A, which would be 69, and then maybe we want an octave above the original, so 5, we'll put in 72. Note, by the way, that there is a very specific syntax to this. Your index must be followed by a comma, and it can only be 1 value, and then whatever is assigned to it needs to be followed by a semicolon. And by the way, it doesn't just have to be 1 value, it could be several values, it could be a list of stuff. But it must be succeeded by a semicolon. So we've got that. Now the way you close a col object is to and save its content is to click on the red button. So you don't go to File and Save, you click on the red button and then you press Save, and that should be saved with this object here. So again, if I double click on it now, the same thing comes up and it has been saved, so that's good. So what we're going to do is we're going to insert that col object below the table, so between the table and this number box. And that means we need to modify the table. At the moment this table runs from 0 to 127, but in fact our col object, as we remember, only runs from 0 to 5. So I'm going to change the range of the table so that it only shows me the values that I want. I'm going to change the range to, well, I'm going to give it a range of 7. Now there were only 6 values, 0 to 5, so 0, 1, 2, 3, 4, 5 is 6 values. But I'm going to put in 7 because I'm going to allow myself a rest. I'm going to allow myself a row where if I click on it, nothing will happen. So when I do that, then everything disappears off the end of the table. It's still there, by the way, it's just we can't see it. It's just kind of off the end of the table. So I'm going to, basically, I'm going to draw in all the way along the bottom row, like that, and that obliterates everything that we can't see and would therefore be anomalous if we try to play this back. So if I play this back now, then we just get C's. Okay. Okay. So putting in values into the table like that gives us a little tune based on our pentatonic scale that we've made available. Again, it's relentless at the moment until I put in rests at the top, at which point it has a number which it can ignore because the number 6, as you can see the Y value here is 6, doesn't appear, whoops, sorry, that's the wrong thing to double click. It doesn't appear in my col object. Of course it could appear in my col object, if I wanted to increase or continue the scale upwards, I could do so. So I could have 6, which gives me D above C4, and so on. That's something for you to do if So with a combination of table and col, we have a constrained set of notes which allow us to build tunes, which is all to the good, I think. So what's the next thing in my list? Ah, yes. So now if I were to close this patch now, then we would lose this data, which might be annoying if you've made a very pretty tune that you want to remember and save for posterity. So there is an object which will allow us to save the state of this table and recall it later. So if I put in preset as an object, then that gives me this object which contains a series of nodules, each one of which can contain a preset. And all we need to do is, well, I am going to connect the left-hand outlet of this to the object that I want to save. Preset works in a particular way by recalling the state of all objects. If you don't connect the left-hand outlet to anything, it records everything on a particular page, which is great, but in some instances where you have a start and a stop button, then it will recall the state of that start and stop button when you save the preset, which means of course sometimes it will either start or stop what's going on when you trigger a preset, and that's not ideal. So anyway, I'm just connecting it to the object that I know that I want saved. Lock the patch, and then to save a preset I press the Shift key and then click on the nodule, and you'll notice that it subtly changes colour, and that tells us that that preset has been saved. I could then write in another sequence in my table and then save another preset and then another preset and so on. So I now have 4 presets, and if I don't press Shift but I press the those nodules, then it takes me back to the states that were saved. So that's a very handy way of saving presets for a single table object. So we can listen to those. Okay. So we have a way of producing a sequence, we have a way of saving that sequence. What else might be useful? I'll leave you to try increasing the number of notes that your table and your col will produce. And also, well, I mean, this is pretty obvious really, you can duplicate the entire engine so that you can produce polyphony. Anything within that red box, if we duplicate it, we can connect that up and we will get polyphony with that. Now I'm not, the preset will only save the presets for this original table. It won't save it for this new table. So if I wanted to save presets for that one, I would have to make another preset object. But anyway, this will work. Turn down the volume because it's, there you go. And rather helpfully, just by choosing that pentatonic scale, we get something that is tolerable just by choosing the pentatonic scale. Right. So one other thing that perhaps I'm going to get rid of this duplicate, but of course you could make more than one duplicate, and just depending on the complexity of your tune, you could make something quite pleasant in terms of there being several of these tables to running concurrently. I'll show you an example of that in a minute. What else? Yeah, of course we can change the octave of any of these. So if we did have another one running at the same time, we could change the octave by just adding 1 to the pitch that's coming out of there. So that'll transpose everything up by an octave. Oops, what it should do, what's going on? Has that worked? There you go. Sorry, that transposed it up by a semitone, I beg your pardon. If I want it to go up by an octave, then we add 12. And by 2 octaves, 24. So again, if you have two of these running concurrently, you could have one that's being transposed up an octave and one that's left as it is. Or of course you could simply change the values in the col object. I've made a 25-minute video, so I'm going to stop there for the time being, and I'll come back to this in another video.